Hello everyone, welcome to Chai Commerce Entertainment. So if you're a person who is looking forward how to write a Makefile and understand the intricacies of it, of course you have clicked the right video. So let's get started. So this particular video is part of embedded system playlist. I would like to encourage you guys to click the link above here, and of course I have given the link for that in the description box. I encourage you to watch all the series of the videos. And in my previous video I had explained how compilation steps work, that is build process, and of course I have also showed how to download the ARM32-bit compiler for it. So why exactly ARM32-bit compiler? In my embedded system playlist, I'm actually using this particular microcontroller, STM32 nuclear board, that is L053R8. So that's a microcontroller that I'm using, and this particular microcontroller is based on ARM32-bit processor, which basically ARM Cortex M0. So that's the reason I asked you to download the ARM32-bit compiler in my previous video. So I would encourage you guys to go and check the video. So the link for the click the link of that video here, and of course you can also check in the description box as well for the particular video. Even that particular video is part of my embedded system playlist. So anyway, moving further, so before even continuing, I would like to give you an introduction about the concept of cross compiling. So what exactly is a cross compiling? So in your programming classes, you guys learned to write the code, right? So you did write the code, you compiled the code, and you ran the code on the same host machine. The host machine could be Windows, Mac OS, or Linux, whatever the host machine that you guys used in your programming classes. However, coming to the concept of cross compiling, you actually write and compile the code in the host machine, that is Windows machine in my example, and you execute in the STM32 microcontroller. So the target is different. So the writing and compiling is on a different platform, and execution is on a different platform. The whole process is called cross compiling. So you compile on one platform, you execute on other platform. So in my case, I'm actually executing on STM32 microcontroller, which is based on ARM32-bit processor. So that's the reason I showed in my previous video how to set up the ARM32-bit compiler. So let's continue further. Alright, let's continue further. So in my previous video, I hope you guys follow that video and did set up the ARM32-bit compiler on your platform. If you are not done, please go back to that video and rewatch it and download like the way I have explained in that video. Now continuing further, I want you to search for something called as Make for Windows and click on the very first link. In the very first link, click on the setup program and you will see an automated downloading. So download will happen, that is Make. And once the Make is downloaded, you will see this. Click on this and do the installation. I have already done the installation. Now that I have already done the installation, I would like to show you. So it will be the default path will be on program x86 and GNU and this one. So I would just put this path in the environmental variables. So let's open the environmental variables and environmental variables path. The path is already here. Now the path is already here. So I want you to open the command prompt and try issuing a command called make. So you should be able to see this particular error. This is until now the part two of the setup. So the first setup is downloading the GCC compiler, 32 GCC ARM32-bit compiler, and the second thing is downloading the make and then setting up in the environment variable. So if you are actually working on Linux or Mac OS, you don't have to do this like installing the Make for Windows because the Make is already inbuilt in Mac OS and the Linux. So that's an advantage. So you could skip this part. So if you are working on the Windows host machine, please follow this particular path. And also make sure that you download GCC compiler, which is ARM32-bit compiler, by following my previous video. Anyway, till now you're done with the setup, the basic setup. Now actually we can get started with the actual core of this video, that is writing a Makefile. Okay, let's get started. So here is my dummy project. I have just created a dummy project. It is of a C file. So the C file, in the C file, like in the C project, there is main.c and dummy.c. So dummy.c has bunch of getters, that is dummy val and the dummy name. And C file will actually print those dummy val and dummy name. So that's a bunch of, that is what main.c has, and dummy.h has a prototype for those getter functions. So this is bit of my dummy project setup. And in my command prompt, I have actually navigated to the folder for the dummy project. And in my previous video, like I have explained that arm-none-eabi-gcc is actually used for compiling the C code. If you are writing the C++ code, you should use this. So that's what I was trying to tell in my previous video. So I would encourage you to go back and watch my previous video. And so yeah, so keeping that in my mind, I'll start using this arm-none-eabi-gcc to compile the C code because these are all C code. Now, as usual, I'll type arm-none-eabi-gcc. And like in my STM microcontroller, I told you this processor I'm using is actually based on ARM processor platform. So like what kind of ARM processor is it? I have to actually mention. So basically ARM has different kind of processors. So I have to mention what kind of processor. How to mention ARM different kind of processor. So this is as for the way to mention is MCPU equal to Cortex M0. So this is STM32, the one that I'm using. It is based on Cortex M0. And also I need to use something called as thumb instruction. So because the concept of thumb, I'll explain you a bit. So what exactly is the thumb is? Basically, it's whatever the assembly code that it generates out of C code that will be of 16-bit width. So in microcontroller, usually they don't have enough memory. So that's the reason most of the time for microcontrollers like STM, you are supposed to enable the thumb instruction so that whatever the assembly instruction you use, that is of width 16-bit. And here about optimization. So, I'll for now you don't worry about the optimization. I'll explain further what exactly it is and what kind of standard C programming you need to use. So of course, like we have C99, C11, C10, whatever it is, and you can also use C11, but I would prefer using GNU C11. Why exactly I'm using GNU 11 over C11? So the main reason being for embedded system application specific, like I will be writing the linker script, the startup code about the ISR placement in upcoming videos. So for most of the because of so to support all of these things, all of these features, and also like I'll define something called as attribute section whenever I'm writing the linker script. So to support all of those things, GNU is actually recommended over C11. So if you're just writing normal C code without embedded application, you can go ahead and use C11. But if you want for embedded, GNU 11 is most recommended. So these are the major compiler flags. I'm using this one to compile C code and it specify on what target it should compile. And this one says that you need to generate the 16-bit instruction while 16-bit wide instruction, and I'm saying no optimization, and I'm using GNU 11, that is C11 standard. So yeah, all of these features, if you want to use all of these features, GNU standard 11 is should be used. And I would enable all the warnings. So WA all means enable the warnings. That's what it means. Now, next, what I'll do is C means I'll say compile. Don't go and generate elf everything as such. In my previous video, like I explained you, right? Like for the compilation step, like for the last step is elf. But for the elf, we need a linker script. So I don't have the linker script yet. Right? So that's the reason I'm just saying asking compiler to just compile and compile what. So for now, I'll say source main.c. So I have to specify the main.c is in source and produce the output. So to iPhone O stands for output, and let's say I'll create an object file, relocatable object file. So that is main.o. So this is what the syntax that I'm using. So these are all actually flags until here. And these are all, this is the input and this is output. So iPhone O is output. So compile the input file that is source main.c and produce main.o. Let's see what is going to happen. I'm getting some error, cortex in. Oh, sorry, the spelling is wrong. It should be Cortex M0. I said Cortex M0. It appeared as Cortex M0. Let's see what happens. Okay, so I'm seeing that dummy.h is not found. So how do I include dummy.h? Because I'm including dummy.h, right? So somehow I need to instruct the compiler to say to include dummy.h. So the dummy.h is in include folder. So the best way is, so I'll go by, I'll rewrite this code. I'll rewrite this command. So after writing all the flags, I'll give the path for include. The way to provide the include path is using capital I, and so this is a name of the folder include. So this is how we give. So that compiler will see dummy.h. So let's see now. Till now, I got it was able to compile. I'm able to see the warning. For now, let's ignore the warning. So let's not worry about all of this warning. I'll take care of this later. Now, I got main.o, and since I'm not worry, let's not worry about compiler error. Sorry, compiler warning. So let's actually compile the it is giving some error here in the dummy.c. Okay, iPhone is missing. So that is all the dummy. Okay, dummy.o has no warnings. I'm able to compile it successfully. Okay, guys, till now, let's assume we have only two .c files in this case. That's the reason I was able to run this individually. Let's say like what if I have 10s and 20s of .c file? So will I be able to individually compile like this? Obviously, no. So we should have some automated script to compile everything, all the hundreds of files, like whatever the hundreds of files, like there are hundreds of .c and hundreds of .h files. Without even manually compiling each individual .c file, so we have to come up with an automated script to compile everything. So what is that automated script? So that automated script is called Makefile. So we use Makefile to compile huge number of files without doing the manual assistance. So whatever I did like this, these are called manual assistance. So how to write a Makefile? So now I'll activate the .o file. Now to write the make file, I have to create a new file. Like this is how you actually give exactly the make file. I'll move this outside. Okay. So the make file, this like you should able to see this M symbol, and this is exactly the way you write the make file. Now I'll actually give all of this command inside this make file. So first and foremost thing, like I said, I need to use something called as what kind of compiler I'm using. So that is ARM-none-eabi. So that I'm create so because of which I'm creating a variable called CC, and I'm for the variable I'm giving arm-none-eabi-gcc. So this is how you give the make file. Now these are all flags, right? So these are all compiler flags. So including the warning. So I'll actually segregate the warning flags and the compiler flags. So I'll create a variable called C flags. So there that means compiler flags. So I'll do mcpu. I'll write mcpu equal to cortex and 0, and I'll actually copy paste all of this until this one. Yeah. Next, I'll create warning flags. To the same C flags only, I'll create warning flags, but I would like to append here. So the way to append in Makefile is this is a syntax plus equal to. So enable the warning. Also, I'll just add a comment saying that this is a compiler flags and this is a warning flags. So the way if I had if I had plus equal to, it will actually append to the compiler flags only, this warning flags. So that until here, it is all the C flags. Now, if I now the next thing is this one, include path. So I'll create another variable called include paths equal to I include. So the capital I and the name of the folder that is include. So this is a folder. The name of the folder is include. Okay, now I need to create a target that is output. What is the name of that output? Main.o. Using what? I should use colon. Using what? Using dependency of main.c. So the main.c is in source folder, src folder, src main.c. So this is a target, which is output, and this is dependency. So that's a target and dependency is actually the language of the Makefile. So I would from now instead of me calling input and output, I would like to call it as target instead of output, dependency out of Makefile. And now I need to give receipt. Receipt. What exactly is the receipt? So basically the command. So whatever the manual command that I gave here, so those are called receipt. I hope it made sense. So these are all manual command is called receipt. So this manual command needs to be translated via Makefile. So let me actually follow the same order. So the name of the compiler. So the name of the whatever the name of the compiler and the compiler flags and the include and then target and sorry the dependency and the target. So this is how I do. So what is the name of the compiler? The name of the compiler is CC. So I'll to use the name of the variable, this is always a dollar $CC. So this is actually a syntax to use the variables. And again, use dollar symbol and C flags. Whatever the variables that I have created so far, I'm using that, using the dollar symbol, dollar include files. Now I'm asking you to compile. That is source main.c, the main.c that is present in the source folder, and produce the output -o main.o. So let's see uh, if our compiler behaves the way we expect. So like in order to run the Makefile, we need to use command called make, M-A-K-E, make. Okay, I'm getting all the commands. So that is arm-none-eabi, arm-none-eabi, and the flags until here, the flags until here, and the include path, and the C source, and the C source, and the dependency. Sorry, the target. That is a target. So dependency, that is input output, but I would still can use dependency and target. And why am I seeing it as and recognize command and option? MPC. Oh, it should be CPU. My bad. That's my bad. Okay, let me show compilation now. Again, run make. Cool, I'm able to see it. Now, this is about main.o. Now I want to compile dummy as well, dummy.c file as well. So again, the target is dummy.o and source dummy.c, sorry, dummy.c, give the receipt. I would like to copy paste the receipt. The receipt nothing is nothing but the makefile command. And instead of main.c, I'll call it as dummy.c and dummy.o. So again, let me give command called make. Main.o is not up to date. What does that mean? Let me delete it. So you saw a problem, right? Like if I deleted the main.o and issued make command, and I'm seeing it is actually compiling only main.c, but it is ignoring the dummy.o. So what exactly should I do to include all the files inside the source file? There is a best way, there is a good syntax in the make command. So let me remove all of this. So the way to do it is like instead of giving individual names, use a symbol percentage for this. And for dependency, you need to use a symbol dollar carriage and the target that is output dollar at. So for dependency, oh sorry, dollar carriage symbol and dollar output. Let me see if this is going to work or not. So it says no targets. So this is not enough. So that's the reason we have to use something called as wildcard. So what exactly is the wildcard? So wildcard is actually one of the keyword that is supported in the make file that actually fetches all the contents inside a source file. So how to use that? So for that, I'll actually create a new variable called c sources. C sources is equals to again wildcard. So again sources. So for this syntax, you need to use star or asterisk dot c, and this is a dollar symbol. So what does wildcard do? So it will inside the source folder, how many number of C files are there? Those numbers of C file will be used to compile. So wildcard, like if there are hundreds of C file, so it will iterate list all of them, and this will compile. This will issue command for each of the C file. So this is a syntax to use the wildcard. Now, whenever I compile a .c file, I need to have a equivalent.o file. So even for that, I need to use some command. I'll show you what exactly command. Before that, I'll delete this main.o. So for that, I'll create a variable called objs. So objs is equals to, I'll say, whatever the C source that I had here, convert that into .o file. This is a, so this is a syntax percentage needs to be used every time. And I'll create something called as all here. All for all, I'll use objs. Now, if I give make, it will come here. It will come here first. I will go to all and it will try to resolve C sources. C sources will be the wildcard that is dots, dummy.c and dummy.main.c. Everything will be listed here in the form of list. So let me try to run now. Why I am seeing this way. Okay, so I'm using include paths here, but it is not taking include path here. Why? And the order is completely different. What is going on here? Okay, I found what exactly the problem was. So there are two odd things. So one thing is missing the include. Yeah, missing the include this one, even though I'm including it, I don't see it in the command. That is one odd. And the second odd is I'm seeing source dummy.o. Like, why am I seeing this source dummy.o? Source SRC is actually the folder name, right? Why am I seeing the directory name or the folder name? So why am I seeing this? Why am I seeing this? So to understand this, so this particular command will give that is this will serve so list dummy.c source main.c main.c. And this line will convert dummy.c and main.c into main.o and dummy.o. But the problem is source is already included. SRC is already included. SRC folder is already included. Because of which I'm seeing this odd thing. And I don't want this behavior. Because of this behavior, we are seeing this odd compilation issue. So how to get rid of this? So, the source is actually a directory, right? So, like we have to mention the make file saying that, hey, whatever the thing that you're using is not the directory. So what is the syntax to say not a directory? It's very simple, straightforward. You need to use something called as NOT, not dir, not directory. Of course, you need to use dollar every time. So this is the syntax. You need to use not dir command or not dir keyword and with this syntax. Now let's see if it is able to compile or not. So I'll say make. Cool, I'm able to see it, right? See, I'm like that's like as expected. I'm not seeing source dummy.o and source dummy main.o. I'm just seeing this. So when I say not dir, source dummy.o becomes just dummy.o. Similarly for main.o. I hope it made sense, whatever I explained. So if you didn't understand so far, please ask me in comment section so that I'll explain you better. Anyway, so till now we have somehow managed to write the make file. Let's try to improvise the make file. So how can I improvise the make file? So remember whatever the object file that has been generated, the relocatable object file, I want it to transfer into a separate folder. I'll create a new folder. Inside that folder, I'll redirect all the object file to the new folder. So how can I do it? So I'll create a folder. I'll say mkdir. So that's a make directory or object, and this is a command, and you have to use shell make command make mkdir. So it means mkdir obj this mkdir obj this command mkdir obj whatever the command that I executed manually, the shell command, the shell keyword will execute through makefile. So this obj folder will be created through makefile. I want to do that. So for now I just deleted it. I wanted to create through makefile, and whatever the dummy.o or the whatever the object file that has been created so far, I want it to redirect through the obj folder. So till now, like wherever I see .o, I'll replace with obj. So obj. So this is the syntax. And here we don't have to worry about it because here dependency will be translated like this only. And here also I need to use something called as add prefix. That's a keyword. Add prefix obj slash. So basically dummy.o will be translated to obj dummy. This is how it's gonna get translated to. I hope it made sense. And as usual, I'm using this dollar symbol every time. You need to use this dollar symbol whenever you add some keyword. So let's see if it is able to generate obj file and transfer inside that obj file. Redirect all the object file inside the obj file. Okay, I'm able to see this main.o and dummy.o getting executed, and ta-da, I'm able to redirect to it. Okay, this is one search of cleaning. And let's fix some compiler warnings. What is this compiler warning? So then the dummy.o, I'm using percentage %d. Oh, it should be percentage %s. It should be percentage %s. Yes, because I'm printing a string, right? Okay, one warning went away, and there is another warning. It says, um, return type of main is not int. I'm using void. Okay, for some reason it is expecting me to have int return type. That's fine. Open 0. Anyway, it will not reach here. Regardless, it is fine because I'm having a while model loop, right? It will get hanged. So the code will be hanged here. So it's fine. Now let me compile. Yeah, I'm able to compile. And what is this subdirectory already exist? I need to get rid of this warning. The way to get rid of this warning is use something called as. So this warning will be silenced. Two greater than, and null. So if you use this command, this warning will be silenced. So let's see if I'm able to see. Okay, I'm not able to see this warning anymore with that. And let me try to delete it manually and issue main make. Cool. It is able to compile both main.c and dummy.c that is present in all source, and all the object files are directed into obj. So obj is created and then they are redirected inside here. Okay, guys. For now, I would like to end the video here for this video. So in my upcoming video, I will actually improvise this Makefile even more. So before even improvising, I need to write the linker script. Till now, if you go back to my previous video, I have explained the compilation steps. That is preprocessor, compiling, assembling, and the linking. So this three steps of preprocessor, compiling, linking has happened. So because of which I'm able to get the relocatable object file. So the final step will be the else. So I need to have the linker script for that. So in my upcoming video, I'll be writing the linker script and the startup file. And what exactly the startup file, I'll be explaining in my upcoming videos. So till now, thanks for watching. So stay tuned for my upcoming videos. And this make file is not completed, just for your information. It will be improvised a lot. So thanks for watching this video.